Welcome to MEM30007 Select Common Engineering Materials. My name is Matthew Behrens. In this presentation, I will provide a brief overview of the material selection process and offer guidance for completing Assessment Task 5, the refrigerator and washing machine material selection task. Now, before we jump to the assessment task, I'd like to ask the question, why is material selection important? Firstly, I'd say to ensure the selected material can withstand the operating environment and meet all engineering and performance requirements. Selecting a material with suitable properties, such as strength, hardness, corrosion resistance, or thermal stability, helps avoid premature failure and ensures the product performs as intended throughout its expected lifespan. Secondly, I'd say to confirm that the materials are cost effective in terms of purchase, processing, and ongoing maintenance. Cost effectiveness in material selection involves more than just the initial purchase price. Engineers must also consider processing costs, including machining, forming, or heat treatment, as well as other long-term maintenance or replacement expenses. And finally, I'd say to ensure that the materials are sourced ethically and support environmental sustainability. This includes ensuring materials are not sourced from conflict zones, are mined or produced with fair labour practices, and have low environmental impact in terms of energy use, emissions, or recyclability. Prioritising sustainable material contributes to the corporate social responsibility and aligns with regulatory and community expectations. Poor material selection can lead to significant performance issues, safety risks, and increased costs over a product's life cycle. Using incompatible materials can result in galvanic corrosion, where two dissimilar metals in contact with an electrolyte, such as salt water, create an electrochemical reaction that rapidly corrodes the less noble metal. In plastic components, improper selection may lead to failure through UV degradation, stress cracking, or softening under heat if the polymer's thermal or mechanical properties are not suited to the application. Such failures can result in product breakdown, costly repairs, environmental harm, or even injury, highlighting the importance of careful and informed material selection. On the far left, we've got an example of poor material selection. The failure in this case was likely caused by internal stresses within the T-connector that exceeded the long-term strength of the PVC material. This led to plastic creep, progressive crack growth, and ultimately creep rupture. The characteristics of the T-connector were consistent with failure under relatively high stress. The forces contributing to the failure was linked to hoop stresses generated by interference fit between the hose bib and the T-connector. In the middle there, we've got an example of galvanic corrosion. So the less noble material, or the more anodic, has corroded, and in this case the nut and the washer have. So over a prolonged period of time, it will continue to corrode and will make it difficult to service this assembly. That is, to unscrew that nut without causing some sort of damage. On the far right, we've got an example of a plastic pipe that's failed. It looks like the material has become brittle, potentially due to exposure to UV radiation or an incompatible chemical. Material selection is a critical step in engineering design, and it can be effectively guided by tools such as the Ashby method and finite element analysis. The Ashby method uses material property charts to visually compare and shortlist materials based on specific performance indices, such as strength to weight or stiffness to cost ratios, allowing engineers to make rational, data-driven decisions that align with the design requirements. Once candidate materials are selected, FEA can be used to simulate how these materials would behave under real-world loads and boundary conditions. This process helps validate the material suitability by identifying potential areas of stress concentration, deformation, or failure. Together, the Ashby method and FEA provide a complementary approach. Ashby charts narrow down the options, while FEA confirms the performance, resulting in optimized, reliable, and cost-effective material choices. When evaluating a material's suitability for a specific application, it is important to take a comprehensive approach by considering its physical, mechanical, and chemical properties. We'll start with physical properties. A physical property describes the characteristics of a material that can be observed or measured without changing its chemical identity. Examples include density, melting point, thermal conductivity, and color. Now, mechanical properties. Well, a mechanical property defines how a material responds to external forces. It includes characteristics such as strength, hardness, toughness, ductility, and elasticity, important for determining how a material performs under load or stress. Chemical properties. Well, a chemical property describes how a material reacts with other substances. This includes corrosion resistance, flammability, oxidation, and chemical stability, which are critical for understanding the material's performance in specific environments. When explaining why a manufacturer has chosen a particular material, you must base your reasoning on its physical, mechanical, and chemical properties. In addition to considering the physical, mechanical, and chemical properties, we must also consider manufacturability, cost, and sustainability. A material must be easy to machine, form, or assemble using available manufacturing processes. Otherwise, production may become inefficient or require expensive tooling. On the right there, we have an example of injection molding. Injection molding is a highly efficient process, and it's used for producing complex plastic parts in large volumes with consistent quality. It supports manufacturability by allowing intricate shapes and features to be formed in a single operation. While the initial tooling cost is high, the low cycle times and minimal waste make it cost-effective for mass production. Many thermoplastics use injection molding are recyclable, supporting sustainability goals. Cost is equally important, as overly expensive materials can make products uncompetitive or economically unviable. On the right there, we've got an example of sheet metal forming and bending. It's well suited for producing durable parts with excellent structural integrity. It's highly manufacturable, especially for medium to high production volumes, as it requires relatively simple tools and machinery. The process is cost effective due to the fast production rates and minimal material losses. Additionally, metals like aluminium and steel used in sheet forming are widely recyclable, making this method a sustainable choice in many applications. Manufacturers are increasingly using materials that are recyclable, have low environmental impact, and are ethically sourced. Now that we have some understanding of the material selection process, I'd like to ask the question, in this case, why did the manufacturer select polycarbonate for the CNC protective window? Now, a few reasons would come immediately to mind as obvious, that being that the material needs to be transparent, optically clear, so that we're able to observe the workpiece as it's being manufactured. In addition to that, we need to provide the operator with some level of protection in case the tool comes loose or breaks free and is ejected. So we need a material that's tough and impact resistant. But in order to get the complete list, we need to consider the physical, mechanical, and chemical properties of the material, as well as we need to consider manufacturability, cost, and sustainability in order to get a complete picture of the reasoning behind the material selection. We've identified that the manufacturer has selected polycarbonate for the protective window on the CNC. Next, I'd like to explore the reasons for that. So we'll start with the physical properties that are favourable in this application. So to begin with, we've got high transparency, which allows for clear visibility of the machining process, which is essential for safety and monitoring. The material is lightweight, so it's easier to install and handle compared to glass or metal alternatives, reducing strain on hinges or mounting structures. The material itself is thermally stable. It maintains its shape and strength across a wide range of temperatures, typically found in a workshop environment. Next, I'll move to mechanical properties. So polycarbonate has exceptional impact resistance. Polycarbonate is virtually unbreakable and can withstand flying chips or tool breakages, providing excellent operator protection. It has high toughness, resists cracking or shattering under sudden loads or shocks, and it has good dimensional stability. It maintains its shape under mechanical stresses, ensuring it stays securely in place over time. Finally, we'll look at the chemical properties that make this material favourable. Firstly, it's resistant to oils and coolants, so it can withstand exposure to lubricants and cutting fluids commonly used in the CNC environment without degrading. It has low water absorption, which prevents swelling or warping over time due to humidity or coolant spray. And polycarbonate has moderate chemical resistance. It can resist many cleaning agents, making it maintenance easy without compromising the material. We'll now consider manufacturability, cost, and sustainability. So starting with manufacturability, polycarbonate is easily machined or thermoformed. Polycarbonate sheets can be cut, drilled, bent, or formed without cracking, making them ideal for custom-fit protective windows. It can be fabricated rapidly, supporting efficient manufacturing workflows. Next, we'll look at cost. So polycarbonate is lower cost than glass for safety applications. While more expensive than some plastics, it's cheaper and safer than laminated or tempered glass when impact resistance is needed. It has a long service life. Its durability reduces replacement frequency, lowering long-term costs. It's a material that has minimal tooling requirements, reduces setup costs for low to medium production runs. Finally, we'll look at sustainability. Now, polycarbonate is recyclable. Polycarbonate is an example of a thermoplastic, meaning offcuts and end-of-life products can be recycled easily. Polycarbonate is lightweight, reducing energy that's used in the transport and handling of this material. And the durability of the material reduces waste. Its long lifespan minimizes the need for frequent replacements, decreasing material consumption over time. So now that I've considered the physical, mechanical, and chemical properties of polycarbonate, as well as manufacturability, cost, and sustainability, I can now provide the reasons why the manufacturer selected it. So on the left there I have my material, polycarbonate, and the use case, which is a protective window. And for the reason for the selection, I've said polycarbonate offers excellent transparency and is lightweight, allowing clear visibility of the machining operations. Mechanically, it's highly impact resistant and tough, capable of withstanding flying debris or tool failure without cracking or shattering. Chemically, polycarbonate or Lexan resists oils, coolants, and cleaning agents commonly found in workshop environments. From a manufacturing perspective, it's easy to cut, drill, and form, requiring minimal processing. Lastly, polycarbonate supports sustainability goals as it is recyclable, long-lasting, and lightweight, which reduces both material waste and transport-related energy use. So now that we have a good understanding of the material selection process and a comprehensive way to justify material selection in engineering, I'd like to take a look at the refrigerator and washing machine material selection task. The assessment task itself can be divided into 4 parts. The first part would be identifying 4 materials used in the construction of the refrigerator and washing machine. I recommend specifying a particular grade and type of material because the properties can vary greatly. You're required to give the reasons for the manufacturer's selection. Once the tables are complete, you must send a consultation email for both, that is the refrigerator and washing machine. So you're required to send 2 separate emails there. Thirdly, you need to write a comprehensive report. So I'll provide a template, and you're to only consider the relevant data. That is the properties that are relevant to its suitability for a particular application. MatWeb is a great source of information for material data. And finally, you're required to complete an ergonomic checklist, which is at the bottom of the assessment task. Question 1 asks that you examine a basic domestic refrigerator and identify 4 of the materials used in its construction. You are to give the reasons for the manufacturer's selection for their choice of material, and you need to complete this table. So on the left, you need to select 4 materials, and next to the material you must state what it's being used for. Finally, you must provide reasons for the selection of that material. You must consider the physical, mechanical, and chemical properties of the material, as well as manufacturability, cost, and sustainability in your response. Once you've selected your 4 materials and provided the reasons for the selection of those materials by completing the table in question 1, you are then required to write an email to your assessor requesting confirmation and consultation on your selected materials for the refrigerator components. Your email must adhere to the following criteria. Include a clear subject line, a polite and professional tone, and provide a brief overview of the project and the purpose of the email. Mention the selected materials for each component and briefly describe their properties in relation to their functions. Request your assessor's feedback, suggestions, or any additional guidance they may provide regarding your material selection. It's important that you address all 3 of these dot points. Like question 1, question 4 requires you to examine a washing machine and identify 4 of the materials used in the construction. Give the reasons for the manufacturer's selection for their choice of the material and complete the table below. So in the material column, you simply select your 4 materials and state what they're being used for, and then provide the reasons for the selection, considering the physical, mechanical, and chemical properties of the material, as well as manufacturability, cost, and sustainability. Just like the previous example, you must send a confirmation and consultation email with regards to your material selection for the washing machine components. Your email must adhere to the following 3 dot points. Once you've received a response to your confirmation and consultation email, it's time to write your reports. You're required to write 2 reports. One of the reports would be on the domestic refrigerator, and the second would be the washing machine report. In both cases, you'll need an aim, analysis, and conclusion. In your aim, you're required to provide a brief overview of the task and its importance, including identifying the suitable materials and the role of material selection in the performance and durability of the appliances. The aim can be found in question 2 of the assessment task sheet. In your analysis, I recommend listing the 4 materials, and next to the material, you should state what it is used for. Then you would go on to list the physical, mechanical, and chemical properties. So for the physical properties, in point form, you could include the density, weight, thermal and electrical conductivity and appearance of the material. Under mechanical properties, you might list the tensile properties, toughness, ductility, malleability, fatigue, hardness, and creep resistance. And under chemical properties, you'd look at corrosion resistance and compatibility with cleaning agents and detergents. And again, this would be in point form. Please note that you must research and specify the properties that make the material favorable for the particular application. For example, if you state that the material has been selected because it is a good electrical conductor, specify its electrical conductivity. If you state that the material is low density, specify its density. You can get these properties from MatWeb or other online sources, for instance. And then considering the physical, mechanical, and chemical properties, discuss the reason for their use in a domestic refrigerator. You must consider factors such as the cost of the materials, manufacturing processes and requirements, as well as performance, reliability, and sustainability. You're required to write a conclusion. Your conclusion should be written discussing the properties of the materials related to the application. You're also required to write a report on the selection of materials used in a washing machine. The report format is the same as a domestic refrigerator. In your report, you must include references for all data that you present. For instance, if you state that a material has low density, you need to provide the actual density value along with a valid source. MatWeb is an excellent resource for finding material properties and is considered a reliable reference. To conclude, please remember to upload all the required documents to Connect. This includes your completed assessment task sheet, your email consultation with the assessor's response, and your final reports. If you have any questions or need further guidance, don't hesitate to reach out to your assessor for support.